So today we're solving one-step equations. It's right there. There we go. Now, what we want to do is we want to look at the equal sign in an equation as kind of a balancing point, almost like a teeter-totter or a seesaw, depending on what you call it. So whenever we do something to one side of an equation, we have to do it to the other side of the equation to keep the equation balanced. So, for instance, suppose we start with the equation x plus 7 equals 4. And I want to know what value of x will make that work. Now, attached to that x right now is a plus 7, and I've got to get rid of the plus 7. And so to get rid of a plus 7, I do the opposite of plus 7, which is called an inverse operation. Some words you're going to want to remember. Inverse operation. So what is the inverse operation of addition? Ryan? Subtraction. So in order to get rid of a plus 7, I subtract 7. But in order to keep my equation balanced, if I'm going to subtract 7 on one side, I have to subtract 7 on the other side. Bless you. Your sneeze. Now immortalized on YouTube. So we're left with x on the left. What do we have on the right? A negative 3. Ooh. So we believe that negative 3 will be the solution to that equation. The best part about algebra is we can check our answer. Take that negative 3, put it back into for x in the original equation. Does negative 3 plus 7 equal 4? Yes, it checks out, so x does in fact equal negative 3. Everybody good so far? Let's look at the other half of that. X minus 12 equals 3. I've got a minus 12. I want to get rid of it by doing an inverse operation. So what would be the inverse operation of subtraction? David? Addition. I'm going to add 12 to both sides. So subtraction is the inverse of addition. Addition is the inverse of subtraction. It's a reciprocal relationship. Okay? They are each other's inverses. So on the left, if I have a minus 12 and I add 12, they cancel each other out, and I'm left with x. What's 3 plus 12? 15. What should we do now? Check our answer. Does 15 minus 12 equal 3? Yes. Awesome. So our answer is x equals 15. Everybody good so far? So the inverse of addition is subtraction. The inverse of subtraction is addition. What's the inverse of multiplication? Ryan? Division. What's the inverse of division? Multiplication. They work together. So if I have a multiplication problem, negative 6x equals 48. I have something being multiplied by the x. How do I get rid of what's being multiplied by the x? Sarah, how do I undo multiplication? I divide. And if I do it on one side, I have to do it to the other side. So we're left with negative 6 divided by 6, or negative 6 divided by negative 6 is just 1. We're left with just an x. What's 48 divided by negative x? Sorry, negative 6. There's an x in 6. This is close enough. No. You have the right sign. Negative 8. A positive divided by a negative is a negative. So we have a negative 8. What should we do now? Check it. Does negative 6. Now make sure you put this negative 8 in parentheses. Because if you don't put the negative 8 in parentheses, it's going to look like you're doing negative 6 minus 8. And that's not what the original problem says. Does negative 6 times negative 8 equal 48? Yes. So the correct answer is x equals negative 8. How are we doing so far? Plugging right along. Let's look at one with division. X over 4 equals 5. So x is being divided by 4. How do I get rid of division? How do I undo division, Miss Stanford? Yes. Multiply by what? 4, because that's what's being divided by. I'm going to multiply both sides by 4. And I get x equals, what's 5 times 4? 20. What do we do next? Check our answer. Does 20 over 4 equal 5? Yes. So x equals 20 is our answer. Everybody good so far? All right, now for everybody's favorite topic. Fractions. I love fractions. Except for when we're talking about like pies or pizza. I'm not a big fan of fractions of pies or pizza because that implies I'm not eating the whole thing. And that's disturbing. Okay? So let's try this one. Negative 2/7 x equals 4. Now, here's the trick. That negative 2/7, how is it attached to the x? How's it attached to the x? Yeah? Multiplication. Now, how do I normally undo multiplication? Division. Okay? The opposite, the inverse of multiplication is division. But when we divide by a fraction, what do we normally do when we divide by a fraction? No, we don't go to decimals. We multiply by the reciprocal of the fraction. We flip it over and we multiply. Okay, so when we're dividing by a fraction, we flip and multiply. So what do we get when we flip negative 2/7? Negative 7 over 2. Okay, that's called the reciprocal. It's also known as the multiplicative inverse. Okay, so when I multiply a number by its reciprocal, what do I get? What do I get when I multiply negative 7 over 2 times negative 2 over 7? Not 0. 1. I get 1. Whenever I multiply a number by its reciprocal, I get 1. Think about it. Multiplying those fractions, I'd have 14 on top, 14 on bottom, and 14 divided by 14 is 1. What is 4 times negative 7 over 2? Somebody says negative 14. Anybody agree with them? Let's see. Let's take it in 2 steps then. When we're multiplying by a whole number, we can put that whole number over 1. 4 times negative 7 is negative 28. 1 times 2 is 2. That reduces to negative 14. Or, you could have reduced. You could have said that 4 can reduce down to 2, with the 2 that's on the bottom reducing down to 1. You still get negative 14. What should we do now? Check our answer. Does negative 2 over 7 times negative 14 equal 4? Put it over 1. We get a positive 28 over 7, which is equal to 4. So negative 14 is the correct answer. So to get rid of a fraction that you're multiplying by, multiply both sides by the reciprocal. That's only when it's multiplication. If we were adding a fraction, we'd get rid of it by subtracting the same fraction. Okay? The only time you multiply by the reciprocal is when you were multiplying to begin with. So let's plug this into a nice real-world problem. In the 2004 Olympics, a long, long time ago, you guys were that's the year you were born? That's disgusting. Okay? That's disgusting. I got my associate's degree that year. Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter. Well, let's see. We've got distance, we've got time, we need to find speed. We need an equation that relates distance, time, and speed. Distance equals what? Rate or speed times time. Think about it. Someday some of you will unfortunately be driving your own vehicle. If you multiply your speed by how long you're driving it by, that will tell you how far you've gone. So let's plug in what we know. What's the distance? He ran 200 meters. That's a distance. What's the speed? We don't know. So we need to put a variable there. What variable do we want to represent speed or rate? S. That's a weird looking S. That's more like a Greek letter. There's an S. What's the time? 19.79. So we're solving for S, and we have a number attached to it by multiplication. How do I get rid of it? Divide both sides by 19.79. You're going to have to do that one on your calculator. I don't expect you to get that one in your head. Although you should be able to approximate it, because 19.79 is almost 20. So 200 divided by 20 is going to be around 10. So what should we come up with if we plug it into our calculator? I'm sorry? Nope, it's going in the wrong direction. 10 point, we'll round to 10.1. Now what are the units going to be? Let's see. He ran 200 meters in how much time? 19.79 what? Seconds. So what units would his speed be in? Meters per second. It's got to be a rate. Meters. He ran meters per second. Okay? The units for our distance divided by the units for our time. Meters per second. Does that make sense? Are there any questions?